So the most important thing is that you need to go through this passive documentation. Right? The API changed and I need to make modifications in the code, but the documentation is very clear, right? Very clear and very good. I would say it is better than my class. Okay. Definitely you go through this documentation in 1 day or 2 days, you will be able to finish it. This weekend, try to spend some time on SPACY documentation. And if you have any questions, right, you can call me and we can discuss. This is very important. To solve NLP problems, SPACY documentation is very important. Okay. So in the last 1 month, what we covered is the most important thing for the industry. That's unfortunate, right? Unfortunate that we are covering it in the last, but without understanding the fundamentals, I cannot cover this. That's the problem there. And as Girigaru said, right, I need to create the document, the diagram where, which actually shows where we are, right? So it's like mall. You went into a big mall and you don't know where you are, and you look at the map all the time, right? Like that, I need to create the diagram. So I'll create that. But last 1 month, what we covered is the core of that AI, and what is industry ready stuff is there. But you need to focus on that and try to learn, because it will be useful for you and sometimes maybe me also, right? If I get a project and I don't have resources, you all may help me, right? So that's another selfishness I have. Okay. So let us start this very exciting recurrent neural network concept. Okay, recurrent neural network is used in time series problems. Okay, self-driving cars. The RNN is used to predict whether there is going to be a turning or a bump, or a U-turn, or it's going to predict, right, what is going to happen in future based on what it has seen so far. Okay, the difference between the DNN, CNN, and machine learning models and RNN is that it is a time series thing, right? Time series thing in the sense you look at 10 time steps and you try to predict what is going to happen in the 11th time step, right? Depending on all the 10 time steps, you are trying to predict what is going to happen on 11th time step. What is the difference between that machine learning and deep learning? There, what you do is you take all data, all historical data, right? You have, let me take an example, right? If you are trying to predict stock price, stock market, stock price of a company, if you use machine learning or deep learning, right, the DNN or CNN, what you do is, to some extent, maybe CNN we can use. No, maybe one dimension. No. So in DNN, CNN, and machine learning, what you do is, if you have 12 years of data, you take all 12 years of data and try to build a model and use that model to make prediction. Okay. If you look at a stock market data, the code is already present in our blog. I'll use that same code. If you look at stock market data, right, it's going to be like this haywire, right? I took around 12 years of data. 12 years of data, and all 12 years, right, the data is like, beginning the price is so low. When IPO was opened, the price is so low, and in between it actually went up, went down, went up, went down, and it's all different patterns are there. If you use this data, whole data, and build a model and try to predict what is going to happen today, tomorrow, will you get a good model? Will you get a good prediction? That's a question.
No, sir.
No, right? Because the pattern is changing quite often, right? So till here there is a pattern, till here there is a pattern, till here there is a pattern, till here there is a pattern. Right? Depending on previous 10 steps or 20 steps or 30 steps, today's pattern is going to be, right? So that is what an RNN does. Recurrent neural network looks at last 10 steps or 20 steps or 30 steps. You can decide how many steps you want to look at. You can decide. It looks at it and then makes a decision. That is the difference between the machine learning, DNN, CNN, and RNN. RNN is altogether different. So time series problems can be solved. Sequence, it actually looks at sequence and tries to make a decision, right? Right? The vehicle turning, right? Whether there is going to be a curve or not actually depends on the city in which you are present and the maybe the block in which you are present most of the times, maybe, right? There may be patterns in blocks, right? If you are in a gated community, the patterns inside gated community are going to be specific, right? If you are inside a industry, right? It's a maybe BHL. Inside BHL, the town is pretty much planned well, and the township and the plant are pretty much planned well. And if you know maybe 2 3 lanes, it's all going to be same, right? So you can use that 2 3 lanes pattern, and in the fourth lane you can actually predict whether it's going to be a curve or not, especially in a controlled environment. If you are trying to build a robo, RNN can be used to predict whether you are going to get a curve or not in the in the next step. Got it? That too depending on next 2 3 streets, or maybe 200 300 feet or 200 300 meters of road. Got it? Right? It will change. Maybe you are entering from plant to township. Right? When you are entering plant to township, the road may be a different way, but inside township, it's going to be different way, and inside plant, it's going to be different way. So it will be predictable. But inside a city, maybe it is a bit difficult, right? Most recently planned cities are most recently planned countries like America, right? Very young countries like America, right? India is a ancient country. We'll have all chaos because it's been planned or unplanned, and especially for last 70 years, it is most unplanned, right? Most chaotic, right? Or maybe last 200, 300 years, right? It became like this. So we may not be able to predict and may not be able to do things well. But in countries like America, young countries like America, right? You can build self-driving cars which will use RNN to predict whether there is going to be a curve or not. That too depending on past 2 3 lanes or maybe 200 300 meters of road, right? But the whole country's data is not going to be useful to predict next you are going to get curve or not. So the machine learning and CNN, DNN are like that. It will take whole data to understand pattern and use that pattern to make predictions. But RNN will use chunks of data, that to time steps we call them as. Okay. So in a nutshell, there will be time steps, right? There will be time steps from 1 to T. There may be n number of time steps in your data set. When I say n number of time steps, right? I have taken 12 years of 12 years of stock price data. Okay, I have taken 12 years of stock market data. Okay, there may be for each year there are going to be 365 days. Maybe working days maybe 200. Take 200 as working days, right? Stock market working days. 12 years means 12 years means 2400 days are there. Okay, in your data set 2400 time steps are there, right? Out of those 2400 time steps, you have taken T time steps. N time steps are there in your whole data set, but you are looking at T time steps to make a decision on what happens at the T plus 1 time step. Okay, got it? Got it? Right. there is a minute difference between DNN, CNN, and RNN. Okay, that minute difference is in the way we represent data. That's it. If you understand data representation, right, the rest is all simple. Okay, so did you understand? N time steps are there in your data set. 2400 time steps are there in your data set. When I am saying time steps, right, January 1st, 2008 or maybe 2009 is my first time step. January 1st, 2009 is my first time step. And 2400th time step is January 1st, 2021. Okay. Out of those time steps, right, to predict January 2nd, no stock price, I may be considering last 10 days, right, from December 21 to December 31st, maybe December 22nd to January 1st. I am considering those are the time steps. The January 2nd stock price is dependent on. Okay, January 3rd stock price is dependent on December 23rd to January 2nd time steps. What are time steps? The stock prices of those 10 days will determine the 11th day's time step. Okay, so this is called as unrolling network through time. Whatever the representation I am showing here is called as unrolling network through time. Okay, generally RNN network is shown like this. Okay, see here I actually kept a notation of ReLU, but this is generally in an RNN network. This activation function is going to be tan H. Why tan H? We'll talk about it later, but generally it is tan H. When you look at this node, right, this is one cell, a simple RNN cell is generally represented like this. You pass X, you pass Y, and in between there is a hidden state which is going into itself, right? It is not going into itself. It is going into the next time step like this. You pass X, you have Y, you have a hidden state which is going into the next node. You will have X here also. X2 is going to be here. X2 is passed into it as input. Along with X2's input, you are getting input from the previous node. What is that? This is actually the understanding it got from the first day, or December 22nd stock price you passed here. It understood something. This understanding is fed into the second node along with December 23rd's stock price. Let me take a screenshot and explain. It will be easier for me to talk also. I am actually shouting a lot today. See, suppose that I am trying to predict stock price of Keshava. You may have problems that may need RNN to solve in your company, new company, because it's a financial company, right? There'll be time series problems. Try to focus and do some exercises on it.
Okay.
Mute yourself. There is noise in yourself. So we are trying to predict, stock price on Jan 2nd, X T plus 1, right? T plus 1 time step. You are trying to predict, right? This is December 22nd stock price. Okay, you fed this stock price to the first model. This is sigma is a linear combination, and you are substituting that into ReLU. Generally it is in RNN, right? It is that what do you call it is tan H. I should have kept this tan H notation here, but I did it long back, and when I did it, I didn't notice. And after doing it, I noticed, and I generally don't change things. So that's okay. So it is, it is taking December 22nd stock price understanding, and the understanding is passed to the next layer, next node, and along with the December 23rd stock price, right? The understanding is passed to the next node, right? And then along with the December 24th stock price, like that it is going to be. So what is happening here? Each node is getting an understanding from the previous node and along with the current node, right? What happens then? These 10 days, right? This day, this 10th day is actually helping the Jan 1st stock price to understand what was happening before. Based on that, the decision is made on the T plus 1. But in deep learning, right, DNN, what happens? It actually takes all the data, right, and then it actually tries to predict here. So there is no particular sequence followed here. Here a particular sequence is followed, and only a particular set of values, set of T time steps are actually looked into. Here you pass all n records, and you try to understand. And there are multiple nodes which are trying to understand and pass the understanding to the next nodes. And here also you can have multiple nodes, right? We'll talk about that. Multiple layers, multiple nodes you can have. But the difference is that it is actually looking at T time steps to make a decision on the T plus 1 time step, as the understanding is passed to the next layer. The hidden state, you call it as understanding, or this Y itself, the Y cap itself is hidden state. In most of the cases, whatever the node predicted is going to be hidden state, and it will be passed to the next layer, next node. Got it?
Yes, sir.
Give me 1 second. Give me 1 second. Okay, so that is, generally it is represented like this. It looks like it is feeding something to itself. No, it is not. When you unroll this through time, it looks like this. Okay, it is all notational stuff. People, the guys who actually do, they actually try to confuse people so that people spend time, right? They can actually do this kind of a diagram, right? A simple diagram, or maybe they can put dots here, they can put a dots here, something like that, and they do this, and people get confused. It's going into itself, or then they read. There will be 3 pages of lot of documentation on it, a book, big book to sell and all that. I generally don't like wasting time, right? So you can feed a vector or a scalar as input to each node, and a vector as or a scalar as output you can expect, and a vector or a scalar as hidden state also. See this here. In the example I explained, right? I said that I am passing the stock price only. You can actually pass stock price, volume, opening price, closing price, right? A record you can pass here. The x1 can be a record, a vector, right? X2 can be a vector, x3. When you are passing a vector here, right, it is all going to be same dimensional. If you are passing a 4-dimensional vector, 4 values vector, this is also going to be 4 values. This is also 4, 4, 4. Equal dimensional vectors will get, all time steps will get equal dimensional vectors. Okay, you can pass a vector and expect a y as a vector or a scalar, and hidden state can also be a vector or a scalar. Okay, that's where things get a little complicated. Okay, so that is RNN at high level, right?
Sir, one question, sir.
Yeah.
Yeah. Here, along with H1,
Hmm.
Y1 also will be passed on to the next cell, sir.
This y1, right? that's a that's a good question. Right. Here, suppose that you are passing, I'm trying to find an example where you need every node in the RNN is trying to output something, where you need that kind of a model. I'm just trying to think. Give me 1 second. Give me 1 second. Yeah. Yeah. Suppose that, right? You are trying to cartoonize a particular movie, right? Cartoonize a particular movie, or uh, somebody, somebody dancing, somebody is dancing. That video is like around maybe 5 minutes video. You wanted to make that video as though a cartoon picture is dancing. Cartoon is dancing, or the person's cartoon is actually dancing. Right? What you do is you take time frame, you take frames of that person, that video, right? 5 minute video. Maybe you got 100 time, 100 frames there. Okay, 100 frames. The first frame, you used some GAN here and converted that frame into a cartoon. Second frame, cartoon. Third frame, cartoon. Fourth frame, cartoon. Like that. You pass your video, you get a cartoon video. For every input, there is an output. Then you actually will have Y1, Y2, Y3, and so on. If not, right, you will not have that. Let me show you. 4 different kinds of networks are there in RNN. One, you pass one input and one output. This can be done with DNN or CNN. No need of this, right? You pass, you pass n inputs and n outputs, like the way I actually was explaining, right? Right, that is one way, right? The other way, right? This is the kind of thing. Okay, there is another way. You pass n inputs, only one output. This is like you are passing 10 previous days stock prices. You are trying to produce today's stock price, predict today's stock price, right? This is called as sequence to vector or sequence to scalar. Okay, and you pass only one input and try to generate n number of outputs. This is called as vector to sequence or scalar to sequence. When this will be done, you pass a in music generation, you pass a node or note, I don't know, and it generates a music out of it, right? It generates multiple outputs, right? You pass multiple outputs, multiple inputs, and you generate multiple outputs like this, not in parallel, right? In sequential, you pass a sequence of inputs and sequence of. This is actually language translation. You send English, you generate Spanish, right? The Spanish sentence is dependent on English sentence. The sequence is actually generating sequence, right? So RNN is special in that way. You can actually do a one-to-one, or many-to-one, or one-to-many, or many-to-many networks. Did I answer your question, or went into something else?
Yes, sir.
Right? So the hidden state is generally YCAP only. Generally, whatever the node generates is actually taken as YCAP. But in LSTMs and GRUs, I think in one of them, I forgot, LSTMs and GRUs, hidden state is going to be different. It is calculated. It's a little more intelligent way of, generating output and generating hidden state also. We'll see that. Maybe tomorrow we'll see what is LSTM node, and they are nodes basically. Instead of using ReLU node here, or instead of using TANH node here, you use a LSTM node or GRU node. It's a node in RNN. Generally, people doesn't even know that LSTM is a node. Okay, they say LSTM network. What is LSTM network? There is no LSTM network as such. It's an RNN with LSTM nodes. Okay, so people talk like that in industry. They talk like that. Okay, they don't even try to understand and they talk. So you can understand when somebody is saying LSTM network, right? You can understand that guy doesn't know completely. Okay, it's a node. That node is intelligent in producing YCAP and H. I kept Y here because there will be a cost function between that YCAP and Y and whatever. Okay, and you are going to pass X and Y and build a model. This YCAP and Y, there is going to be a cost function which will adjust the weights here. Again, the same gradient descent. Adjusting weights will happen through gradient descent only. Same process. Whatever we have seen in linear regression, the same process happens here also. Okay. Any other questions?
Yeah, it's probably the analogy I'm just thinking, sir. As you already made a statement.
Yeah.
In case of DNN, it's like processing all the records. In case of RNN, only a subset or some n number of records and
Yes, sir.
using that to make the prediction instead of
Yes.
everything, because the data is fluctuating. Maybe is it
Yes, sir.
a high level analysis? Is it
Yeah,
correct?
it is correct, and it is correct. In a time series problem, data is fluctuating. Seasonality and trends will actually affect the data, right? Depending on seasonality and trend, you need to decide the number of time steps you want to look into. Festive season, Ashadam sale, right? There you'll have a lot of sale, right? So if you try to build a machine learning model and try to predict, sales, it will not work well because it takes the whole data, right? Maybe 10 years of data and tries to predict it. But if you use RNN, right, only that period it actually looks into 10 days, 10 days, 10 days, and it will capture the pattern properly.
Okay, sir.
Yeah, good. So let us look into a little bit of, a little bit of, I'll just go into a little depth into the theory, the math, okay? Even if you don't understand, don't worry, right? But if you understand this, right, it's going to be easier for us to, form the data set, okay? So it is like chicken and egg problem. Should I show the theory first or code example first? Is kind of a problem. So I will show both, and then tomorrow again we'll look at it both. Then you will get it, get more clarity. It's like when in our childhood, right, we were trying to learn riding bicycle. First day, second day we'll fell, and third day, fourth day we'll get it because the mind is actually calculating how exactly the patterns of the bicycle and how to make it stand and all that, right? Like that, I'll try to induce everything and then we'll mix it and try to understand. Why am I trying to do that is myself, I took a lot of time in understanding these concepts. Once I understood, I'm saying these are all easy, but you'll also take some time. Don't be worried. Just keep thinking. It'll actually, you'll get it. 24/7, you should think about this only. Then you'll get it. Yeah, so here in this, right, I said there is input passed, and then there is a hidden state also passed, right? So from the second node, we got hidden state, but for first node, there is no hidden state because there is no previous node. On January 1st, maybe 2009, there is no hidden state, right? So we'll pass zeros vector. If this vector is of size 4, then we'll pass zeros vector here. So why am I saying 4 here is in our stock market example. Let me show you. I think I had drawn it. Sorry. The data is like this, right? There is date. I should not have considered date, but initially with lots of enthusiasm, I use the date also. So opening price, high price, low price, volume, I should take and try to predict closing price. Okay, that's the problem. Opening, high, low, volume, and predict closing price. So 4 input variables: open, high, low, volume are the 4 input variables, and closing is the y variable. Okay. So to do this, right, what I need to do is I need to consider maybe 20 time steps or 30 times. Maybe I consider 60 time steps. Okay. When I say 60 time steps, the data set is going to be like this. First record is going to be like this. Row 1 to row 60. What is row 1? Date, forget about date here. Opening, high, low, volume. Y is closing price. Okay. 60 time steps. Instead of taking only one value, I have taken vector here. Right? Vector with 4 values. Or 5 values. In the diagram it is 5 values. You can see the numbers, right? No need to see numbers, but the structure you can see, right? Right?
Yes, yes, sir.
This is first record. Okay. Just remember that. In first record, in X you have 2-dimensional array. Right? 60 by 5 is the dimensionality of the input. The output is one value. Second record, row 2 to row 61, day second to day 61th day, and taking 62nd day's closing price as the output, right? Like that, if you farm the data and train an RNN model, right? RNN model, the first time checks x1 is going to be this row, x2 is going to be this row, x3 is going to be that row, x60 is going to be that row, and y is going to be 5.94 whatever. Right? You pass all these 60 values, generate some value, and compare it with this 61st day's closing price. Right? That is one iteration. Second iteration, it takes row 2, row 3 as a time step 2, and row 61 as time step n, right? 60 time step, and then it generates some value, looks at row, right? The closing price of 62nd day, and tries to calculate cost. Again, it adjusts the weights, takes row 3, row 4, row 62, and row 63 as the output. Like that, it understands. Ultimately, if you have to predict today's price, you take past 60 days as input and pass it to the network. It will predict today's price. Got it? How we are farming the data set is more important here. Did you understand?
Sir, why is it a why predict? We are actually saying row 61. When we pass row 1 to row 60, we are actually predicting the next day's stock price.
Yes.
Not the one of the day's stock price.
Yeah, you can do either that one also. If you take 60th day as the output variable, you can predict today's price. Today's closing price also you can predict.
No, the representation, sir. The right side representation, Y close, we said, right? It should be a Y cap, right?
No, why? Close is the closing price. Sorry, this is in the data set, right? The closing price.
But
Price.
that closing price is actually sent 60 times for each record. And the only one is outputted,
No, each
which
record.
is
No,
byproduct.
no, wait. We will not do for each record. I'll talk about that. That's the difference. You are thinking that's good. That's the difference between RNN and normal, deep learning, machine learning algorithms. I'll talk about that. Just try to understand this input data structure and output data structure. Right? I have taken 60 rows and 61st closing price as Y. It is Y only, not Y cap. I am constructing a supervised data set here. X and Y I am constructing. I'll tell you, I'll explain you. In 5 minutes, right, you'll understand what your confusion will be clear. This part is clear, right? I'm constructing a data set here.
Okay, so instead of saying this record one, is it a iteration one kind of stuff?
No, it is record one.
Record one only.
In iteration one, in epoch one, iteration one also it will become. Right? If you have 100 records, right? If you are sequentially doing it, the first record is the first iteration input, right? Second record, second iteration input. Third record, third iteration. One epoch is over m records, right? Again, second iteration, second epoch. Again, first iteration, first record. If you are not randomly choosing.
Okay,
whatever
sir.
you said is true. Whatever you said is true. Even for machine learning or deep learning, machine learning or RNN, CNN, anything is true. Whatever you said is true. Got it? Can I move on?
Yes, sir. We will try to complete to some logical extent.
Yeah. That's better. Even I was about to say that.
Yeah.
Okay, so this is opening. This is low. This is high. This is volume. Suppose that. Okay. XT. I took one time step in this whole 60 time steps. I took one time step and expanded it and trying to show you. Okay. In the node, in the RNN cell, right? I get confused between RNN cell and node, right? RNN cell, there are three, ReLU nodes, right? Suppose that there are three ReLU nodes. What will happen? This particular time step has got 4 inputs. A vector I am passing. That vector will go to, right, this vector will go to this node, orange lines. This vector will go to this node, green lines. This vector will go to this node, magenta lines, right? When I am saying it is going into, right, it's a linear combination calculated and substituting into the equation, that ReLU function, and output is being given. This is y cap. Okay. So suppose that I am generating 3 y's here, not like whatever we have seen there. You can have 1 y also. You can combine all 3 with a dense layer and produce one number also. Okay. So suppose that I am generating 3 y's here. So this is input, right? In a particular time step, this is input, right? If you look at this diagram now again, right? Suppose that this is the tth time step, right? In tth time step, I am passing 5 values into the network, 5 values into the network. So I need to have 60 of them, right? 60 of these 5 or 4 values, right? 60 of them, because in a recurrent neural network, it considers 60 previous days to predict tomorrow's price, right? For 60 nodes, it needs 60 inputs. And one more thing, first day's input processed, the outcome is passed to the second node. Second day's input also passed, processed, outcome passed to third node. Third day's input passed, like that 60 days is passed, and you are trying to predict something out of it and then compare it with y value. What is y value? 61st day's value. Getting it? Did you understand why I created this dataset like this? I converted my dataset like this. For all these 60 values, only one output, because they are all sequentially being processed. This is this is passed to first time step. This is passed to second time step. This is first time step, second time step, and first node, second node, third node, like the 60th node's output is what is compared with this y. Got it? This is one node in all those 60 nodes, 60 cells. Sorry. These 60 cells, one node I have taken and expanded it. Getting it? Shashiram gar.
Now I got why we are sending the output
Yes.
as Y61.
Yeah.
But
So,
this one,
RNN expects the inputs should be passed like this. A two-dimensional array it expects. For all time steps, inputs should be passed as a two-dimensional array. Y depends. If it is a vector, you pass a vector. If it is a scalar, you pass a scalar. Got it? So you need to reformat your data set as time steps and then Y. And then pass it to the neural network. That's it. RNN is done. If you understand this point, right, RNN is done. 99% is done. We'll explain about hidden state and all that in a moment. Did you get it? Any questions there?
Sir, here we are passing the X, sir. Output is Y. Y means it's a Y cap or Y?
See, there will be Y which is produced by these nodes. Sorry, there is a Y cap which is produced by these activation functions. There will be Y also, right? Maybe at this particular time step you don't have Y. Right? Ultimately, at the last node you have Y. I'll show you. No, there is a. I am actually confusing you a little bit, because why you use Y? To calculate cost. Why
Yes,
cost
sir.
is needed? To adjust weights. That's it. But while formatting your data set, you should have Y, because if you don't have Y, the algorithm doesn't know how to calculate weights, right? This is formatting your data set only.
Yes, sir. But as for diagram, like we are passing the X and it's given the Y output, right? Here, X1 and see.
I would have kept Y cap here, but I kept Y here.
Okay,
right?
okay, okay,
Why
okay.
I kept y here is there is going to be y here and there is going to be cast function and these weights are going to be adjusted.
Okay,
It's a
okay, okay.
representational issue, right? The
Hmm.
I kind of try to produce it like a book, but sometimes there are mistakes are misrepresentations. Maybe I should have kept y cap, but my intention was to explain that there is going to be y's here. There is going to be a cast function in between. Y caps will be
Hmm.
here and then the weights will be adjusted, something like
With
that.
this. Okay. Yeah, got it, sir.
Even Seshiram asked it, I think, in one of the whatever. So
Yeah,
let us
sir,
complete.
yeah,
Yeah,
yeah, please.
go ahead, go ahead.
Yeah, I got the representation why we need to take, say set of 60 records and only
Yes.
why 161st record why.
Yeah.
But I need little bit explanation about how these 60 records are being passed as XT02, XT3.
I will, Andy. I will
Yeah,
because in the website, right? We have the diagram. I'll explain.
yeah, sir. Okay.
Before we go there, right? What will happen is, this cell, right? This RNN cell is outputting three values, right? Three y caps, right? And generally, I said y cap is what is hidden state also, right? So there will be three values coming out from the hidden state, right? So ht minus 1 0, ht minus 1 1, ht minus 1 2. T minus 1 time steps hidden state is a vector which is outputting three numbers, right? Our current input is four numbers. Total seven numbers will go as input, and there will be to calculate the your linear combination for seven numbers you need to have seven weights, right? There will be seven weights going into this node. There will be seven weights going into this node, seven weights going into this node. It's going to be 7 by 3 dimensional weight vector, which is going to go into this node. You need to have that understanding to make the network work. There are 60 time steps. In each time step, there is going to be 7 by 3 dimensional vector. So you can understand the complexity or how much memory you need to process each time step, right? To actually train the network, how much memory you need to calculate, like that. So depending on number of outcomes coming from the hidden state and number of inputs you are passing in the current time step, the weight vectors, the weight matrices will be decided, right? Weight matrices dimensions will be decided. Okay, this part I'm eager to explain, right? Explain. So we will see mathematical equations tomorrow. No need, if you understand this, if you get the gist of this, right, no need to look at mathematical equations. Got it? Can I move on? Anyway, tomorrow also we are going to look into this only for next, for at least 10-15 minutes, and then we'll move on to other concepts.
Sir, all these three, what are these three, sir? These are the cells, right? Or nodes?
See, in this RNN cell, right, we have three outputs, right? Do you agree? Three outputs are there in this RNN cell.
Yeah, here we have three outputs, but
Yeah. Here we have means total network will have the same structure. This cell will also have three outputs. This cell will also have three outputs. I just said yt minus 1, yt plus 1, yt, but yt0, yt1, yt2, right? They are the values. Or y cap.
why three outputs, sir?
One cell structure will be followed by all cells. All 60 cells will have same structure, input and output both. Okay. In that way, hidden state will also have three because y cap and hidden state we are saying same. Got it?
So, yeah, yes.
Sir,
So,
go ahead.
yeah. So, this is a kind of layer we can just
Yeah.
understand, like,
Sequential layer. You can say it as a sequential, but there are layers also, right? Like this, you can put in a particular cell, you can put multiple layers also, multiple nodes and multiple layers also. In a cell, you can have multiple nodes. You can have multiple layers also. You can think that as a sequential layer. You can think it as one of the this is one layer. The terminology, right, may be a bit different, but you can imagine like that.
Sir, I think one confusion, the reason for one reason for confusion here is we discussed about the stock price as an example, where there is only one input from the RNL cell.
Yes, sir.
But here we have three inputs, so the problem of stock
out.
price prediction is different,
Yeah.
and this diagram is for a different problem. Is my understanding
Yes,
correct?
sir. Yes, sir. Yes, sir. I agree. You know, I wanted to show two examples at once so that you will understand the capabilities of RNN. It's in hurry.
Sure. No. Maybe it's my misunderstanding. Just want to
No,
clarify.
it is not your misunderstanding. You're actually understanding, and ultimately you'll understand. You know, even if I show two things, right, you will understand. Confusion is good. To get clarity, confusion is good. If you are confused and asking questions, right, then we'll get more clarity. So, intentionally created some confusion here.
Sure.
Now you know, right? An RNN cell can have three outputs or one output. A vector can be an output or a scalar can be output. In our stock price prediction, it is scalar output. Here it is a vector output. Okay. If it is a vector output, right, you will have that dimensionality is coming as input also because hidden state is being fed to the current node.
So, sir, if we need only one output, so how many these functions, right, we are representing sigma?
Yes.
How many
So
we have to take? We have to take only one.
You can take one, or you can put a dense layer on top of it. You can put a dense layer on top of it, which actually takes these three inputs and consolidates it into one number. Dense layer with
But
sigmoid or ReLU or only linear regression.
This is an intermediate cell, right? So this is not the output.
Yeah, intermediate. If you want every cell to every time step to output something, you can put that way. No. I want to have only output at the last layer. You ignore all these. You ignore all these y variables. Ignore all these y variables. Only the last value you consider. I'll show you that example. That whole thing is there. Coming up. But if you understand the structure and the input and the vector dimensionalities, right? I'll move on and show you something.
Sir, this network type depends on the problem we are trying to solve. It's
Yes,
not that
yes.
everything will be applied to everything. Correct, sir?
Yes, and yes. In fact, either it is DNN or CNN or RNN or any network, it depends on the problem we are trying to solve. I showed you sequential and model, two classes to build models, right? The model class gives you the flexibility to build whatever network you want. Depending on the problem statement we should be building or we should be experimenting with different network structures. Okay. So here, if you look at this diagram, you'll understand now. Let me expand it. See that? I am passing first time step, second time step, third time step. There are in each RNN cell, there are multiple GRU nodes. There are multiple layers. I am ignoring all these outputs, only considering the last output because when I say ignoring, right, in the cost function, I will consider only this y cap and pass y and then try to calculate the squared error. Okay, that means I am ignoring these. When I am ignoring these means while calculating back propagation, these values are not considered. That's simple, right? It is. Got it? If you look at this diagram, right, you'll get more clarity now. Isn't it? Here you are getting three outputs for each cell. Hidden state is actually passing three inputs, and you are passing 5 values here. 8 values go. 8 valued vector is actually going into these 3 nodes, and you are calculating again 3 values. 3 values you are passing. 3 values are. But here I actually kept a sigmoid. Sorry, sigma. That means linear regression, right? A dense layer, a dense node with no activation function. It is outputting a number. I am comparing that number with the y cap, y, that y cap comparing with y, and I'm calculating squared error. The back propagation is adjusting the weights. Again, second node, second record I am passing. Second row I am passing. Again, third row, fourth row, like that. You know, multiple iterations, multiple epochs will actually understand. These weights will get adjusted so that it will predict. You know, when you pass 60 numbers, it will predict the next day's start price. Got it? Clear?
Yes, sir.
So when we say here xt0, so we are only passing first record over here.
No, these all 60 are first record. From the data set it is first record, but the formed data set, this is whole formed data set. Give me 1 second. This formed data set is this whole thing went in, and this
Okay.
thing is the y. This whole thing went in, this thing is y. This whole thing went in, this thing is y, like that.
Can you please go up a bit? Okay.
Day 1 to day 60 I passed. Day 61 is the y. Day 2 to day 61 I passed. Day 63 is y. Day 3 to day 63 is passed, and then the 64 is y, like that. Iterations, iteration 1, iteration 2. So you need to format your data set in that way, then only the network will take appropriate values into each time step, rather it will throw error. The network expects data in that format. Thinking?
Yes, sir.
So I'll stop class for today, and then tomorrow we'll start again because it needs some time to digest.